My name is Clayton Parker. I am lead developer at 6 Feet Up, where we specialize in creating highly customized open source solutions using Plone. And we've also been in the Zope hosting business since 2001. So here's a picture of my brother and I fixing some bugs at the last Plone tune-up. We killed a lot. I've been a Python developer since 2003, and I've been using Plone since 2004. We looked at Plone in 2003 at the first Plone conference, and we started using it briefly thereafter. So that was release 2.0, so a bit of a Plone old-timer. My IRC handle is Claytron, and I'll be in the pound build-out room on irc.freenode.net. I'll probably be the only person unless someone else joins and asks a question. The premise of this talk, of course, is build-out. That's one thing we're going to learn about. We're also going to delve into what parts are. And in build-out, we also have recipes. We're going to learn a little bit about how to use the command line with our build-out. And then we're going to delve a little bit into Zope scale. We're not going to get real deep into it, but we're going to discuss how to create your own build-out using Zope scale, and also creating custom recipes using Zope scale. So why build-out? In the past, if you've ever done any Plone deployment or Zope deployment, how many people in here actually have used build-out? Okay, quite a few. How many people were around before build-out? Oh, yeah, still quite a few. So we're all very happy that build-out is around. In the past, we had a terrible time getting all the products, dependencies, setting up databases, doing all sorts of little tasks that you'd have to run down a checklist of things to do, or create your own shell scripts, or it just wasn't easy to do in the past. So build-out gives us a way to put all that stuff into a configuration file, and that way we can check that configuration file in. We can hand it to our other developers, and this helps us eliminate confusion. So in the past, it's did you install the latest product XYZ, and did you install that one package? Oh, but then you need this and this and that. And so getting someone set up just to get started developing on your project would take 2-3 hours, depending on the complexity, and it could take even longer if you run into some really strange dependency error, or you spend a lot of time trying to get those things together. Also, I want to encourage people to ask questions throughout. If you have a burning desire, just raise your hand. I'll get to them. So once we eliminate the confusion, we also want to be able to track dependencies. So in build-out, we have ways to what's called pin to specific revisions or versions of Python packages and products. And it's really been very nice to be able to just hand somebody something, they run it, and you get the setup you want. Currently, to get started, two of the fastest ways, you can go onto plone.org and go to the products, Plone, and download one of the installers. They have a Mac installer. I don't know if the Windows installer is build-out yet. Does anybody know? It's kind of so-so. It's almost there. I tried out the Mac one, and it's really nice. You don't have to know everything about build-out just to get it going. The other quick way to get started is with Zope scale. So with Zope scale, you just install it with easy install. Then to see a list of the templates that are available, you do paste or create. And one of the templates you'll see is Plone 3 buildout. And then you just run paste or create -t, Plone 3 buildout, the name of your buildout. It's going to ask you a series of questions. what the password is for the admin user, what the admin user's name is, all those sorts of things. And when you're done, you have a build out. You're ready to go. To understand what we are doing with build out, there's some lingo we're going to have to understand. The first is probably setup tools. I'm pretty sure everyone familiar with setup tools in here, at least to some degree. It's a really simple way to get a Python package installed. With setup tools, you'll be installing a package, and usually the package is an egg. Eggs are packages packaged up so we can distribute them. So that's what we call an egg. And we put the eggs on PyPy, or the cheese shop. So when you do easy install, like Zopscale in the previous example, it looks onto the cheese shop, finds the package, pulls down the package, looks at the dependencies, brings down any dependencies we need, and we're ready to go. So buildout's doing a very similar thing for us. You can also have your own package server, or with using like the Plone Software Center or Andreas Young's Hoffe.egg server. You can create your own private repository of eggs. So if you're working on client projects and you don't want to just release them to the cheese shop, which I don't recommend, you can put them into a private egg server, and then you can point your build out to use that as well. We also have a couple different types of things we can install into our build out. We have products, so old style Zope2 products, and we have packages. So products, even if they're an egg, when you go to the cheese shop, you'll see something like products.cluso, something for debugging. When you put that into your build out, it installs still in the products namespace. So there's some magic that happens with the products namespace, such as auto-loading configure.html, and running an initialize method inside of your install or your init of the product. So you don't have to worry about adding ZCML slugs and that sort of thing. So a ZCML slug, which I just mentioned, is something that you use to alert Zope that you have a configure.html, an overrides.html, or a meta.html. And some packages will commonly, like in Plone, for instance, they still have products.cmf Plone, and so in their configure.html, they just load in all the other packages you'll need, so you don't have to worry about doing ZCML. But with some of the newer style packages, you have to actually declare that you need to use ZCML. So when you're going to insert a new package into your build-out, you need to check to see if anything is loading it for you, which may not be easy to find out, but you can also just look into the package. If there's a configure, an overrides, or a meta, then you need to put that into your ZCML statement. And we'll go a little bit over that later. So the syntax we use for our configuration is Python's config parser. It's a really simple syntax. I really enjoyed using it because it's so easy to use. And in build-out, they've added a few advanced features to it that make it even nicer. So here we have parts, and we have options inside of our parts, and we'll go over that stuff a little bit later. The advanced syntax that they add is variable substitution. So you can use $ curly brace to reference another part in your build-out. And you can use them inside of a string like the last option there. You can see that we use the variable substitution, and then we add something to it. And you can put it in the middle of something. It's really quite handy. And something new that they've added, well, it's fairly new, is the option addition and removal. So you can add or subtract parts to your build-out config. So if you're extending configurations, you can remove parts without having to rewrite the whole set of parts over again and then add your one part in there. The only time that doesn't really work is if you need to put something in a specific spot inside of your parts. There are some reserved characters. These are the ones that are currently being used. In the documentation it says, beware there may be further special keywords or special reserved characters in the future when they develop new features or reserve them for whatever reason. So we don't want to use these in our part names or option names. So option names are typically separated, white space separated with just a dash. So if you have two words, you put a dash in between them. You don't want to use the colon, obviously, because we saw on the last slide. That's where that's how we do our references between parts. So we talked a little bit about parts. The parts are the pieces that make up our application. So when we have a build-out config, each section is a part. There's one part that will always be there. It's the build-out part, and it has some predefined things for us. And parts are really, like here in the example, we have just one part, and it's an instance. So with this part, we're creating a ZOP2 instance, so a ZIO client. And to install it, we just put it into our parts declaration in our build-out. And next time we run our build-out, it's going to install that part for us. It's really a great way to pass on this configuration. So, like I said before, the getting rid of that confusion. What port was that on? What do I need to set up debug mode on that? And a lot of the time I would go over to one of my coworkers' desk, and I'm like, "Do you have debug mode on?" They're like, "Oh yeah, I got it on." And 10 minutes later, you're like, "You don't have it on. Let's go, put that into your conf and let's get that set up right." So it really saves a lot of time because you know exactly what they'll be running, and it's a really easy way to these are pretty much not all of the zope.conf is in an instance part, but a lot of it is. So it's really highly configurable. So to install a part, we use recipes. So recipe looks at all of our parts, and it will look at the options in our part and then go install it for us. So if we take a look again at the configuration here, so we have three parts. We have clone, zope2, and instance. And parts are in square brackets. A part requires a recipe. So you can't have a part without having a recipe defined. So for instance, for our clone part, we just have recipe equals clone.recipe.clone. And that's as simple as it gets. There's other options there, but that's all you need to get going on with the clone build out. So it'll go grab all the things we need to get started. And again, like our instance part, we're using clone.recipe.zope2 instance. And for our zope2 part, we're using clone.recipe.zope2 install, and that goes and grabs zope, compiles it, and we use that in our instance part, which I don't have there. So when you create a build out, whether you did it through ZopeScale or whether you did it through an installer, you're going to have some default things that show up. So we have a bin directory. That's where all the scripts will be added. Like when you run a zope2 instance recipe, it's going to put a instance script. It's going to be the name of your part. It's going to put the script into the bin directory so you can start up your zope instance. There's a lot of different recipes that add different scripts for different purposes. We have a bootstrap.py, which is what we'll use to get started on our build out. And I think I don't have the commands till later. We'll get into the command line usage of build out near the end. So we have our bootstrap.py. We run that. It's the thing that creates all these directories for us, some of the directories for us. We have a develop eggs directory. That's where that's where links for eggs we are working on get put into. There'll be sometimes when you might have an old develop egg link in there and you might have to remove it, so it's just something to be aware of. We have a downloads directory. So in this directory, when we download or when we go to install a part, it needs the recipe. Or actually, that's not true. That's for eggs. If we're using a product or a recipe like clone.recipe.distros, it's actually going and grabbing tarballs of all the products that Plone needs. And so when it does that, it caches them into this downloads directory. So every time you run your build out, it doesn't like go and grab all these products every time. So anything that's being downloaded and uses the downloads directory, it's going to put it into there. Next we have the eggs directory. So when we run our build out for the first time and we have never run it on our system, it's going to, and you're using Plone, it's going to download a lot of eggs. So there's all the Plone namespace eggs, plone.app, there's the archetypes and the wicked, and all those things will be downloaded automatically for you, and they'll be put into eggs. And if you don't pin a version, you're going to get the latest version of all those eggs. So if we ran our build out 3 days ago, we would have gotten plone.recipeplone 351 or 315.1. If we ran it today, we're going to get plone 316 automatically. So we're going to, whatever updated eggs are in plone 316, they're going to be downloaded into our eggs directory. So we're going to have like a history of all the eggs here as well. Eventually you're probably going to want to go and clean some of that out. If you've been doing one project for a couple of years, you might have like 10 versions of Plone, so you probably want to get rid of some of those. The next we have is the parts directory. So when a part is created, if it has files that were returned in the recipe, they get added into the parts directory. So for instance, if we have a ZOP2 part, when it compiles ZOP, it's actually going to compile it into the parts directory. So we'll have a ZOP2 directory inside of the parts directory. So the contents inside of the parts directory is typically the name of the part. That'll be the name of the directory inside of there. We also have a products directory. This is more of a convention thing. This doesn't get created automatically. I don't know if it gets created automatically or not, actually. When you're developing on a ZOP2 style product, which is becoming less and less the norm these days, you'll put it in here, and I'll show you later how you're going to put that into your build out so it recognizes that folder as a products folder and loads those things up. And then lastly, we have the source directory. So it's the same thing as products, but it's for our packages we're developing. So if we're working off the trunk of something or working on a branch of something, we're going to put it into the source directory, and there's going to be some special commands we give our build out to recognize that and to load that up. And that one's also more of a convention thing. You can put a package you're working on in any directory you want, but most of the time it's going to be source. There's a lot of things in build out that are by convention. Part names, there's nothing forcing you to use ZOP2 as the name as your ZOP2 part. There's nothing forcing you to use instance for your instance part, but that's pretty much what everyone does. So if we're all kind of subliminally agreed on a certain set of part names, it helps out when you're using someone else's build out, because they could really name them Foobar and Baz, and that's your ZOP2 instance, your Zio server, and your ZOP install. So that's something to be aware of, but most of the time you'll see pretty common part names. So build out itself has some predefined options. So some of the things like the bin directory, it defaults to bin, or the eggs directory defaults to eggs. You can actually change these in the build out part. So if you want the bin directory to be somewhere else, or if you want any of these directories to be somewhere else, you can do that. We also have the parts definition, so that tells our build out what pieces of our application we want to install. Because you can have a part in your config, but it may never get loaded. You have to actually explicitly say add it to your parts, so it'll go find that part and load it up. Also, we have a log level. By default, log level is 100, and you've probably commonly seen doing bin build out minus v, and that decreases verbosity by 10. So the more 10s you put, the more you're decreasing the verbosity. So if you want every log message ever, you can just put log level equals 0 into your build out, and you get all kinds of noise. And there's a way to do some defaults. This is probably one of The key things to get set up if you're working with a lot of projects, working with a group of people, it's easier to get all these things set up. So you put this into your home directory in a .buildout directory. So it'd be home.buildout, and this is default.config.cfg. And so here we can set defaults for any of the parts in our buildout. The most common usage is what you see here is in our buildout part, we want a common directory for all our eggs. So if I say eggs directory equals home Clayton.buildout eggs, then every time I run my buildout, if it's going to look into that directory first, and if I've already got Plum 316, it doesn't have to download all those eggs again. You just use those eggs in our buildout. Likewise with the download directory, you don't have to download those things once, and if it's the same version you're using, it's just going to go grab that version and put it into your buildout. And one I just sort of recently started using was the Zope directory, and that's something I just use in the Zope2 install. So you can, or I think it looks at that variable to see where it wants to compile Zope. So by default, if you don't specify, that's going to put it into your buildout. So if you're developing, like say 10 clone applications, they're all 3.1.5, they're all going to be using Zope 2.10.6. You'll just have one Zope 2.10.6 install in your home directory, and all your buildouts will use that to create a new instance, create a new ZIO server, all that stuff. You can also specify an alternate index. I don't highly recommend it because you can only have, setup tools can only have, or distutils, can only have one index. So when you set this, you're telling it to find all the packages on this in this index. It defaults to PyPy, the simple index on PyPy. So if PyPy goes down and you have a mirror of PyPy, you can point it over to that, and it can go find all those packages over there. You can also set up find links and point them to an index. It works similarly. So if you need to do that, like if you have, like what we do at 6 Feet Up is we have what we call a skillet, and we have it's like a private repository of eggs, and we put a find link in all of our buildouts that says go look in the skillet /simple to find that version. That's like all the versions of things we've put into the skillet, and it's going to go find it and then install it. Like I say, you can set a default of any part in your default config. So I put event log equals debug. If I'm ever working on any project and it's not set, I want it to be debug because I want to see all the debug messages. This doesn't override variables in your buildout. So if event log level is set in your buildout config, you're not going to get debug mode. You're going to get whatever's set in your buildout config. They have some sort of experimental hooks to run after your buildout is run, but I don't think anyone's really utilized that too much. So this is just setting sort of default things, doesn't override anything. So recipes, we touched on recipes briefly. Well, first of all, where do we find recipes? Well, we look on the cheat shop. There's a lot of recipes on the cheat shop. If you're coming to sort of a problem or a deployment thing, and you're like, how can I do that in my build out? Well, just look on the cheat shop. There's a multitude of really great recipes on there. You can also look in the collective. There's a build out folder at the root of the collective, and there's some recipes in there. Some of them that haven't been released, but most of them have. But if you're going in there to find something like really new, and or if you can't find it anywhere else, you might check there, see if there's anything. I've uploaded a few recipes into there, actually one that's not released, so there you go. Some common recipes are some clone recipes. So as we saw, there's clone.recipe.clone. That's going to install all the dependencies we need to run Plone. We have a zope2 install. It's going to install zope for us. We have a zope2 instance, which is going to take all of our parameters, set up zope configs, and set up our ZCML and all that sort of thing. And we also, there's things like plone.recipe.squid. So if you need squid in your production configuration, you can use a recipe to set it all up and build it for you. One thing to note is buildout's not just for Python applications. It can be used to build other applications and other Python applications like Django or pylons or whatever you want to use it for. But it's primarily used for Python projects. Let's take a look at another recipe that's quite useful. So with the zope2 install recipe, you can tell it to fake zope eggs. This is really important if you're using some really cutting edge packages. They're going to want to actually they're going to have dependencies on zope3 libraries, so things like zope testing, zope component. And if you don't have fake zope eggs, it's actually going to go download like all of zope3 into your build out. So this fakes it out by putting develop egg links into your develop eggs and points to the eggs inside of your existing zope2 install. So you don't have to pull down all of zope3 and then nothing works anymore. And by default, it's just looking for everything in the zope namespace. So zope dot whatever, it's going to throw a develop egg pointing to your zope2 installation. There are some other eggs you probably want to ignore as well, like ZODB. There's some eggs like some eggs that are going to have that as a dependency, and then that just starts bringing down all zope. If you're using like z3c.form, I don't know if it's still the case right now, but you need some of the newer versions of some packages. So you can say, skip these eggs. I really do want to get the zope3 version for like zope testing, zope component, zope IATN. It'll pull those down, and your application will work. So let's talk a little bit about how we're going to use this in the wild. If you use the installation methods we talked about at the beginning, if you use installer, or if you use the zope scale, you're going to get just a basic, like a build-out config. And that's nice for local development, or for, a lot of times they're used for like plips for Plone. You can set up a build-out with all the things you need to test some plip. So it has like, a couple new packages and maybe different versions, or like maybe the trunk of some packages. It's easy for that, but if you want to use it for sort of the full cycle, you're going to start doing what we call extending. And what we typically do at 6 Feet Up, and it's just really convention. These are all the configs you could possibly have. So you start with a build out config, and for us this is really basic configuration. And then you have several other configs. So you have a base config. This will set up all the common elements across all different types of deployments you'll have. Then you'll have a development config where you can add in like debug products, things you don't want to use on production, but things you want to use locally to enhance your experience. I've set up a debug config which has a lot of the same debug products I use on every project. At some point I want to make a recipe so you don't have to have a separate config for it. You can just install the recipe and it's going to go get some of the, you say what version of Plone you're using, it's going to bring down some of the common tools we're using to debug. You can have a QA config, so if you have a QA server, you can just set up to use this config. And then a production config, so on there we'd set up things like squid, and maybe we have to set up Nginx or pound, all those sorts of things. Put those into the prod configuration. And we're going to take a look at all those. So this is our build-out config. And all it does is extends to another profile. And we set up some common elements that are needed in all of our configs here. And I took it out, but typically we'll have our skillet set up in here as well. So at the top of the find links will be our special URL to find our private packages. So that's really all we have in our buildout config. So the development config is actually using the base config. And so in our base config, we have all the parts we need to get ready to go. So we have we can install pill, and that one only works. It doesn't work on Windows, I don't believe. And to use that part, the pill without TK, you have to have libjpeg and libpng installed on your system. So it's nice to have if you know that stuff's going to be there. There's no, I haven't seen a recipe yet that's going to install that stuff for you, and you have pill. So when you're creating a build out, you need to make sure that the Python you use to create it, if it has a bunch of junk in your site packages, there could be things you're missing in your config. So when you move to another machine, it's not going to work anymore. And that's one we put it in there just so that we know it gets installed, and we know that every machine has libjpeg and libping on it. And so the rest of our base configuration here is basically our clone site, our Zope2 install, our instance, and our Zio server. And we are also, in this example, we're developing a package called my.package. So again, that's the convention. You say develop equals, and then you give it a path relative to the build out of where that package is. Then there's our pill without TK part. There's a package on zope.org that it'll grab and install pill for you. We also have our Zope2 install part, and we looked at that a little bit earlier. Then we have our clone part, so we're just using default settings, so we're going to get whatever the latest release is. We have an instance part, and in here you can set up all your common elements across all your configs. So typically in here it's going to have all the eggs you're developing, all the ones you're using. You need element tree. Clone requires element tree for, I think it's marshalling. We have our ZCML. So in our my.package, if we have a configure.zcml, we need to put the ZCML equals my.package. If you are trying to do overrides in your package, you need to say my.package -override. So the default for the ZCML option is to load the configure. If you need to load any of the others, you can just say -configure -meta -overrides. And there is a product called Egg Tractor that will go look in your source directory and look for those things and automatically add them for you. But I don't believe it will do that like if you're in a production mode. But I may be wrong on that one. And then here we define our products. So we say we're using our variable substitution here. We're saying that we want the products that clone is defined. And you'll notice here we don't put in the buildout directory products directory because we're typically using that for development products. So we don't want that to end up into our production configuration. So we'll add that in later in our development profile. One thing I've been doing recently is setting a time zone. If you're developing in, say, the Eastern time zone and your client's production boxes are in Pacific, if you're dealing with a bunch of events, as soon as you go to move that to production, all the events are going to be off by 3 hours. So it's kind of important to understand that if it's all in the same box, then it doesn't really matter. But if you're moving your instance around, that's one thing that you can do to make sure things stay cohesive and all the times stay the same. Also ran into an issue on FreeBSD with that. Is anyone here deploying to FreeBSD? got a couple. We noticed that on FreeBSD they don't have US/, so we had to use America/ and then the city name. So America, New York here is actually Eastern time zone. You couldn't put US Eastern. If you did that, Zope couldn't figure out what local time zone you were in, and it caused some problems. So if you're on FreeBSD, something I should probably make available, we kind of patched date time, so we could, we have our own little distro of Zope now that has time zone fixes in it, so it brings that down and basically maps US Eastern to America, New York. That was a bit of a pain. A learning experience, but a bit of a pain. You know, if you're using most other operating systems, there is a US, so you should be good. As for other countries, I don't know. I haven't gotten that far. And the other thing to note with that is when you start up your instance using your buildout, make sure to use the generated instance script that gets put into bin. We were also having issues where if you started with runzope that's in the parts directory, it came up and realized you were in the certain time zone, but when you like created a new event, it still used the local time zone that it found. But when you use the instance script, it would figure everything out correctly. So if you're using supervisor, you can actually do bin instance console, and it'll bring it up in the foreground using that instance script. So that's pretty handy. Because normally if you do like bin instance FG, you come up in foreground mode, but it's putting it into debug mode automatically. So we don't want that on production, obviously. So there's a console option you can give it to bring it up in the foreground, but don't turn on debug mode. And our last part here is Zio server. So if you're using a Zio, pretty simple to set up. You tell it where your Zope2 is and what your Zio address is, and I typically put that in my instance part, so I can just reference that there. So this is our development config. So if we look back to our buildout config, we are saying we're extending development.cfg. So when we do that, it's going to load up this configuration right here. And when you load that up, it says, well, I extend base and I extend debug. So it's going to load in all the parts from your base config and load in all the parts from your debug config. And so then from there, we start using the adding syntax. So we can add just one more part to our development configuration. So here we're adding in our debugging parts. So in the debug config, I'll bring that up real quick. We have some parts set up in our debug config. So we say we want to add in those debugging parts and then add in the omelet. Is anyone here using omelet in their build-outs? Wow, just one person. Oh, there's two. The omelet is a really cool thing written by David Glick. You point it to a list of eggs, and it will create a directory in your parts directory called the omelet. And when you open it up, it's a hierarchical version of all of your eggs. So normally, if you want to go find some code in an egg, like say I want to know what plone.app.portlets has in it. Well, I have to go into that. Like if I'm using the eggs directory that's in my home directory, I have to go to my home directory. And if I've been developing for a while, there's like 10 versions of this product, and you don't know which one you're using. So the omelet will actually go figure out which version you're using, and it makes like a symlinked little hierarchy of all the eggs inside of there. So then you can go down through. So the other problem is if like for plone.app.portlets, there's also plone.app. X plone.app. There's a whole bunch of plone.app products. So you really have to dig through a bunch of eggs in your eggs directory to find the code you're looking for. So it's a really nice little product that puts it all in one place, and you can scan down through it and find stuff really easily. I really like it a lot.
Quick question about
Sure.
variable stuff. So you don't actually have to define those in the configure in. If you're extending, those can be defined.
Right. Yeah, the question is, when you're referencing parts, they don't have to be in the configuration you're in. So if you're extending another configuration, you automatically get all the parts you had in the previous configuration. So in this case, we're actually referencing instance, but we're just changing things in it. We're not overriding it. We're just adding things or overriding specific parts of it. I think, let's see, what are we? We are over. Well, I guess we're using the extension for the products, the eggs, and the ZCML. We're not really overriding anything here, but we're just adding in things. Like we're adding in the HTTP address, the ZO address. We're turning debug mode on. We're turning verbose security on. So all the common things you do in a development configuration, we can set up here. And then down below, you can see the products. We add in the build-out directory products. So you can reference the build-out itself using the substitution syntax. So we have build-out : directory, and that is our build-out directory. And if you can add a folder in there, you can add as many folders as you want that have different products. I don't know if you care to do so. But typically we just have a products directory. It's getting to the point now though that we, like at 6 feet up, we don't hardly ever use it because there's not really too many products ZOP 2 style products we're developing on. It's mainly Python packages. And then we also added in some debug products. If we go over here, we have, let's see where they're at. You can add in things like DC workflow graph, PT profiler, things that haven't been eggified yet. You still have to grab those and put them into a products directory. And then you can see we add in the debugging eggs we're going to use and the debugging ZCML we're going to use. So take a look at this. This is probably one of my favorite parts of build-out is being able to just throw this stuff into our development configuration. So we have some eggs. Most things have been eggified. So we have clone.reload, something that Hanno wrote. He sort of was inspired by some other stuff, but he packaged it up so we can use it in ZOP 210. So this is really handy. Has anyone used clone.reload in here? Maybe a couple people. Basically, you go to your instance root /add reload. You get an option to reload your code or an option to reload code in ZCML. So you don't have to restart your instance all the time. So say you're working on a view class. You make one little change. You can just hit reload, and it'll reload that code for you. The only caveat is you can't be using, if you're using decorators on those methods, it won't reload them. So it's really nice package. PDB debug mode is written by Ross Patterson. As soon as you get an error, it's going to put you into a PDB prompt, and you can start inspecting what's going on. We got Doc Finder tab. If you want to know, you can go to any object in the system, click on the doc tab, and you can see all the methods that are available on that object. And it's a little easier than like if you're in a PDB and you like dir an object and you get like 10 bajillion methods and proper attributes on it. You can actually see the hierarchy of how the object gets those different methods. Clouseau, it's just a web-based debug console. It's also nice. Oh, and with PDB debug mode, you can actually, there's a view class in it. You can go add at debug on any object in the system, and it'll bring you up into a prompt on that object. You do self.context, and you've got the object you're working with. It's also pretty nice if you're wondering, oh, what's, I want to know some little thing on this object, so I just go add at PDB, throws me into a PDB prompt. Printing mail host is something that Martin Spelly wrote. If you're doing a lot of stuff with email and you're on your local instance, you don't want to hit that button that emails the whole directory. It sends out like 10,000 emails, and you realize later you just emailed your silly message to like 10,000 people. It's probably bad. This will intercept it and send mailhost messages to the console. So if you join as a member and you have send my login or send my password, it throws that into the console. And you can just copy it right there, paste it in. You don't have to use your email client at all. That's a really nice one. And also helps save a little frustration. The only one here that requires a ZCML is clone.reload. And so if you define it here, we saw in our development config, our development config, you just add in debugging ZCML. So as we add more debugging products, it'll grab them all. A couple others, a lot of stuff there. So we have our sort of old school debug products using clone.recipe.distros. The only ones we're using there is DC Workflow Graph. It gives you a tab where you can go to and you can see visualization of your workflow. And PT Profiler. So if you've got some page templates that are really going haywire, you can turn this on. It'll give you an output of how long it took to run all the methods on that page template. So you can really nail down like where something really bad is happening. IPZope. I don't remember where I picked this up, but I found it in someone else's configuration. Just kind of rolled with it. Has anyone here used IPython? Wow, one guy, two guys, three guys. IPython's great. It's a really extended interpreter. And in the past, there was some sort of like shim scripts you could use to get it to start up in your instance, basically. So with this, it's a recipe that creates an IPZope script in your bin directory, and you just run bin IPZope, brings you up into an IPython interpreter, and there's a IPython profile for Zope. So when you come up, you type portal, and it's your clone site, and you type utils. You can do utils.sync. It'll do like app.p_jar sync. Who can remember that? You can do utils.commit. It'll do import transaction and transaction.commit for you. So it's really nice helper stuff if you just want to like blaze through some code on the interpreter prompt. And then there's ZopePy, which is the same thing except for it just brings you up into a prompt with all the eggs loaded. So you're not actually loading Zope or anything. You can just load it up. You can like say import datetime, and you can start messing with datetime. But you won't be able to mess with anything in your site. It's just a way to quickly test something that make sure it's there, or see some methods on some objects or on some in some packages. So the next config we can add in is a versions.config, and you can see an example of this in the clone.org buildout. You have a list of all the packages you're using, and you're pinning them to a specific revision. So when we go to release, it looks at this. If we look in our, I didn't put it in there. Shoot, I got a typo. In your prod config inside of your buildout, you would say versions equals versions, and you would extend your versions.cfg. And so when you do that, it says that, for each egg we have here, this is the revision we want, or this is the version we want to bring down from the cheat shop, or to load from our eggs directory. Because by default, it's going to go, every time you run buildout, it's going to go find the latest one and bring it down. So what I typically do is run this little command that I think Wiggy whipped up, and it'll give you a list just like this, so you can throw into your release your versions.cfg, and that's really handy. And so in our prod config, we set up our instance to be production ready. We can do things like add in cache setup using our addition syntax on options. We set up the HTTP address, the ZO address. We can add in, we can set the zlog level to critical. So, we don't care about debug messages. We really don't care too much about info messages. We just want critical messages. So, when your application's running and it's logging all the time, it's taking power to do all that logging. So you don't want it to do that. Another one I didn't add in here is you can turn deprecation warnings off. So all those, hey, you're using this method, don't use that anymore. You can turn all those off. It really quiets down the log a lot. And you can also set a ZODB cache size. So this is the number of objects it'll hold in memory. So usually when you go to production, if you have enough memory, you want to set the number by default to 5,000, and that's usually not enough for most production instances. So you can bump that up here, and then you can set up a cluster. So here we're using collective.recipe.zope2 cluster. It's a little recipe I wrote where you can point your recipe to an existing instance, and then you can change some options in it. So here, we want the same setup as our other instance part, but we just want to change the HTTP address so we're running on the same machine. So you just tell it which instance you want to clone. It's going to go grab that part, figure out all the options, and then mix in all the new options you're giving it, and then you have another instance. Currently, most people are probably like creating another instance part, naming it instance 2, using collective.recipe or clone.recipe.zope2 instance, and pointing back to the original instance. So using the substitution syntax, they'll be like instance colon HTTP or instance colon eggs, or eggs equals instance colon eggs in their other instance part. So just pointing back and replicating all the stuff, and then changing the one thing they actually want to change, which was the HTTP address in there. So it's really handy if you're changing your other config, you automatically get all those changes in your other instance. Does anybody have any questions about configuration?
Is this where you would perhaps remove products or eggs that were installed elsewhere?
You could, yeah. I typically try not to leave those in, like, because this is extending I should be extending base config and versions config. Like in base config, we don't have any of those debug products. We sort of mix those in our development configuration, so that when we get to our product configuration, we don't have to remove anything. It's on the same base going up, and that's been working out pretty well for us. Any other questions?
Is there a way, like a minus equals?
Yes, there's minus equals as well. So you can remove options or things from an option.
The options that are available for a particular part come from the recipe, is that correct?
Yes, if you want to know what options are available. Yeah, so, right. I'll repeat those questions. I forgot to do that. One question was, do you need to remove development eggs from or development pieces from your production config? And the answer to that is typically don't want to have debug stuff into our production config. Another question is, where do these options come from? And we're going to go through how a recipe is created here in a minute. The options are set up in the recipe. So, and most recipes have pretty good README. And so if you go to the cheese shop, usually that README is there, displays all the options. Sometimes there can be a typo or something and kind of throw you off. So you have to actually go into the source and figure out what it's actually supposed to do. So the command line, when we first create our build out, we're going to go into our build out. So here we have my build out. We're going to bootstrap it. So you bootstrap it with the Python you're going to use for your zope. So right now we have to use Python 2.4. So I typically just do Python 2.4 to just make sure. I don't want it to bootstrap with Python 2.5 because you run into some pretty weird stuff if you do that. It'll start bringing down like 2.5 eggs and things like that. So I usually explicitly say Python 2.4 bootstrap.py, and that's going to create those directories we talked about earlier. And then as soon as you do that, it creates a script for you called buildout, puts it in the bin directory. You run bin buildout, and depending on the size of your config, it could take a while, and whether you've run it before. And once you do that, then like in our example configuration, we have an instance, so you just do bin instance start, and you're up and running with your buildout. There's some options we can use. -v and -q increase and decrease verbosity. So by default, it's at 100, so you can remove 10 or add 10 to that level. Minus lowercase n and minus capital N is the newest and non-newest modes. So by default we're in newest mode. So it's going to be looking for the latest versions of all the products and packages, or all the eggs that we're installing. If we don't want it to check, we know that we have all the latest, like we just ran it 10 minutes ago. You can pass in capital N, and it's not going to go do all those checks. So that'll speed up your build out a lot. You pass that in, and it's just going to basically, if you already have all those eggs, it's just going to go right past all that stuff. There's online and offline modes. So by default, obviously in online mode, you can explicitly turn off internet checks. So if you want it to go really, really fast, you do minus capital N and little o, and then it's going to just blaze through your build out. But then obviously if you don't have a package or you're missing something, it won't be able to get it. So we also have a socket timeout, which was just added not too long ago. If sometimes one of your find links could be down, like if you're pointing to zope.org's distributions page, if zope.org goes down, it could take, I forget what the default is. Is it 3 minutes or 2 minutes, a minute? There's a default that takes forever, and you can lower it by using the -T. So you're not waiting the whole timeout for every package that it's looking for. And so here's some example usage. The first one, we just want to run build out normally, decrease verbosity a little bit so we get a little bit more information. The next, we want to run it with not checking for anything new, a little more verbosity. Then we can run it, like I said, with non-newest and offline, and that goes really fast. And then again, there's the timeout. So if you know something is down, you can run your build out with -T, like 10 seconds. Give it 10 seconds to try, and just skip it, or you'll be sitting around for a long time waiting for your build out to run. And I think that's something that Tarek's going to cover a little bit in his talk, is making sure everything is distributed and we don't have problems like that as much anymore. So assignments, you can actually do option assignments from the command line. So say you're on your production server and you're just getting it going, but you want to turn it on debug mode real quick. You actually do bin build out instance debug mode on, and it's going to it's when it installs that part, it's going to find that option from your command line and throw it in there. Likewise, you can actually set the log level from the command line, so explicitly. So no matter how many V's you're using or anything, it's going to set the log level to that number. So that's something you can actually put in, into your default config if you always want it to be at a certain level by default. You can also you can intersperse assignments and options. So in the last example here, we have -N. We have our assignment, and then we have another option. So you can mix those all together. So there's also some commands, and I'm not going to cover them all. I'm just going to cover install. It's probably the most useful for people. If you run bin build out install, it's going to install all the parts. So it's the same thing as running bin build out. If you run bin build out install and you specify some parts, it's only going to install those parts. So if you're running your build out and it got to the last part and then it just bombed out, and you go change it, you can actually just install that one part. If we get to a point when our instance didn't get set up correctly, we can just run bin build out install instance. It's also nice if you add a new egg or add in just a ZCML or something like that, you can just run that one part, it'll update it, and then you're ready to go. One thing to be careful about there, though, is when you're referencing other parts in a part, if it needs to be updated, it won't necessarily update that other part. So if you just you have a fresh install and you do bin build out install instance, and you haven't installed your zope2 part, and you have something that's going to bring down a bunch of ZOP3 eggs, it's going to do that. It's still going to bring down all the ZOP3 eggs because you haven't installed the ZOP2 part, which puts all of those develop egg links into your develop eggs. So if you want to get it, up and running real quick, you need to specify in order the parts that you need to add so to get set up correctly. So next we're going to talk about creating recipes. We've gone over them just briefly. It's really pretty trivial to create a new recipe, and I was really surprised at how easy it was. And that's really the bread and butter of build-out, is that it's so extensible through all these different recipes. So if you're using Paster, or if you're using ZopeScale, you can use Paster create -t recipe, and then the name of your recipe, and it's going to ask you questions about the namespace and all the regular Paster questions. And then once you get set up, you have a recipe. So a recipe really just consists of a recipe class, a constructor, which when you initialize it, it's going to set up some of the options, an install method, and an update method. And some will have an uninstall method. It's not very common. You won't see that too much, but there's some recipes that will install things that they'll later, when you go to uninstall, you'll have to actually go find and uninstall outside of the normal recipe. So let's take a look at an example. So this is like a really basic recipe. You have your constructor where in this case, we just have one option. So it's called not mine. And it actually points to another part somewhere else. So when you do that, well, first of all, I should say that when you run buildout and it installs a recipe, it actually outputs the installation information into a file called .install.cfg inside of your buildout. So it has like all the eggs it got or all the options you gave it. And so the next time when it runs, it knows whether or not you've changed something in your configuration. So if we have it set up, we run our build out, then we go in and we change an option in our recipe. Next time we run it, it's going to say, oh, well, this option isn't the same anymore. I need to update. So that's what the update method is for. So the initial time it's going to go through and run install, and it's going to, whatever the recipe is made to do, it's going to do all that stuff and return the Pi module package to check out each of those URLs. And if you in this install method, if you pass it in export, it doesn't work because it actually figures out if you have Pi SVN installed, which you can't just install from the cheat shop. It takes some manual effort. So if you try to do that, it's going to raise an exception and stop the build out. And here, if we tell it, if the log level, if we look back here, it looks to see if we're what level of verbosity the build-out's using. So it's actually referencing another part to get some information that it's going to use in its install method. So at the end, it's going to return self.location, because when it starts up, it sets up the location, and that's the place it's going to check out all these things into. So when we return that, buildout knows that when we uninstall that, we just remove that folder. And update method is similar. It's going through and seeing if we need to, SVN up all of our all the things we've given to it. And then again, it returns the location so that we know what things we would remove if we were to rerun our build out. Does anyone have any questions about recipes? No? All right, well, I've written several, and I was really amazed at how easy it was. when they give you the paster stuff, you run that. You've got a skeleton. You just kind of fill in what you want it to do. It's really easy. That's about all I had for that. Yeah, well, I guess I'm running a little fast. So wrapping up, we went over build out. We discussed, what parts are, how we use them in our build out, how we use recipes. We went over how to, control our build out from the command line. And we went in a little bit to upscale, creating a build out and creating custom recipes. And if you want to learn more, I'll be giving another talk at our Plugin Deployment workshop next month in Indianapolis. It'll be a 2-day event. First day will be talks similar to what you'll see here, and then the second day will be sort of a hands-on workshop day. So you come with all your questions and your build-outs, and we'll do hands-on fixing and learning. Well, that's about all I had. Does anybody have any questions?
Yeah, one of the use cases that was just presented to me last week was using buildout to install a clone instance inside. Is there any recipe for that?
A clone instance?
Right, so that way when you have somebody come in, like a graphic designer, and you just want to give them the clone so they can get started.
Exactly. The question is there a recipe to create a clone site? That's right. So, and a use case for that would be, you have a designer. They don't know how to go in and use the add menu to add a clone site and what the ID is supposed to be and all the things they're supposed to run. Actually, I did create a recipe for that. It's in the collective right now. It's not very polished. Nate Awney was asking me about it. He was asking the same question in the IRC room the other day. And I said, yeah, I've started working on it. I haven't had time to polish it up and release it. So I was like, well, I'll just put it in the collective. So it's collective.recipe.clone site. And what it does is when you run your build out for the first time, and it's going to go check, it's actually going to start up Zope. That's the only downfall to it, is it starts up Zope every time because it needs to check to see if things are there. But it'll start up Zope. You can pass it in, the site ID, the admin user. It's going to check to see if the clone site's there. If it is, it's going to actually run, you can tell it to run a generic setup policy. You can tell it to install products. And so if it's not there, it's actually going to create the clone site and run some initial generic setup profiles. So we've been using this pretty extensively at 6 Feet Up. We kind of cobbled together a clone.recipe.run script, which allows you to do zopectl run and then pass it a script and run that script. The only problem with it is we have to put that script in every build out. So if you make one change to the script, you got to change it in all these build outs. So I finally broke down and made a recipe just for that case. And we actually use it also to help us release and keep our developers up to date. Because you can tell it to, say we're working on my.package, and in there we have a default profile. We can tell it to run that profile every time. So when we run that profile, it updates all our settings. We've also set up some setup handlers. One setup handler to actually run upgrade steps. So it'll run your profile, and at the end, it'll go find if there's any upgrade steps that need to be run, and it'll run them. So it's really nice to I don't have to tell everyone, okay, well, once you get it up, go over into your portal setup, and then click on upgrades, click on that button, and then click on this other button, then you're up to date. And we don't have to worry about it when we go to release to QA or to production. When it runs, it actually runs everything. It's been really nice. And the dependency tracking in generic setup is really nice for that too, because you can point it to one configuration, and in there you can put dependencies. So if you're doing something like you do in Martin's book, where you have a policy product or package, and then you have a content package, and then a theme package, you can load up all the profiles for each one of those packages in that one. So every time you run your build out, it's going to run all that stuff. So that's in the collective. there's kind of a little brutal hack in it I don't like. That's why I haven't released it. But it does work, and we've been using it for quite a while. But I haven't used the actual recipe too much, but I've tested it works, and it seems to be working pretty well. Any other questions? No? All right, well, thank you for your time.